Lisa LaBelle, everyone.
Hello, world. Welcome to the L4 podcast. And what's going on out there, guys? What's going on in your world today? You know what's going on? Trump's out there. He's drinking alien blood, tweeting some crazy shit. That's what's going on. That's what's going on. Women out there, they're not going to get plastic surgery, but they're drinking from plastic bottles. Bitch, you 90% plastic. What you talking about, chump? You already plastic. Who you think you're fooling? Come on now. That's what's going on in the world. Some crazy stuff. Good Lord. We're just all out here. You know what we're doing? You know what we're doing right here? We're retard maxing. That's what's going on. Oh my God. Yeah, that's right. Retard maxing. That means we're doing something that is very involved without getting paralysis by analysis. You go into it, and we're not waiting for the perfect sitch. We're not waiting for the perfect situation. We're just jumping on in, and that's basically the whole, this whole podcast is retard maxing. That's what's going on. So if you're out there and you're like waiting to start a project or start a business, and you're just like waiting for things to be perfect, maybe you need to get a little more retard maxing into your life. And you know what I realized? People who retard max, they're the best drivers. People who have paralysis by analysis, they overthink everything. That makes for a really bad driver. And that's just what I've observed. I have a friend, I'm going to call her C, and I've never driven with her, but I know she's a good driver because we retard max it out. In improv class, sometimes people want to explain things before doing it, like, extensively, and we're just like, let's go, let's figure it out while we're doing it. Let's put all the puzzle pieces together in our head while we're in it. Retard maxing to the max. That's what's going on in our world. That's what's happening. We're just on our pet dragons, going through space-time, playing chicken, jumping timelines. That's what we're all doing out here. We are making our life. We're moving forward, retard maxing, jumping on into the other timeline that we want our life to be on. Beyond the moon. What are those astronauts doing up there? What are they doing up there in that spacecraft going around the moon like that? Are they on the dark side of the moon yet? I think they reached the dark side of the moon. And there's a song called The Dark Side of the Moon, but if I start humming it, I will get nixed on YouTube. And nixed meaning they'll block my podcast, and it's not monetized, so it's not like I can't monetize it because we're not getting paid for this yet. Not yet. Or I say, I don't know where this train is going, but people getting on board. That's what's going. That's what's going on. We're getting on down the road. You can't. I was just thinking with the humming a song, and then you can't do that anymore. Man, you can't do that on the YouTube. You could have Jamie Foxx come into your YouTube into your podcast studio, and he could start singing one of his songs, and YouTube be like, block, you're blocked. Be like, but I'm Jamie Foxx, I'm singing my song, and YouTube's like, no, you don't exist in the real world. Your song exists on the cybers, and we have full control of that, and so we block that. You're not Jamie Foxx. I don't know. Did that make any sense? No, it didn't. None of it, because none of it makes any sense. Good God. That's gotta change, or all of the old songs are going to die. I mean, John Denver, come on, Country Road. I can't. Should I do Country Road? No, I won't do. Oh, should I get the ukulele and start playing it? Ding 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 ding. No, I will not torture you guys with my ukulele playing just yet, but it's coming. Stay tuned, folks. If you guys are out there and you're like having a hard time, get some wind on your skin. Get some wind out there in the open air, because the tree pollen that's going down, so you can go outside now. I'm letting you know. And even for people who aren't allergic, it's okay to go outside because the tree pollen isn't really flying around too much anymore. It's still out there, but it's not that bad. So get out there on a windy day and feel the wind hit your eyeballs. Pop your eyeballs wide open, let the wind just go in there and hit those bichons, hit those retinas. And go right down your spine. And that's the Continental Railroad. The rail line is down your spine and go into your peach, that wind. Woo! That's the connective system. I believe that is the official connective system in the body. The wind hit your retinas, and then it goes down the Continental Railroad line, down your spine, and then to your peach. Nonsense! Okay, so, but the reason why I mentioned that is because, I was thinking I wanted to have the window open when I was driving last week, because I just love that feeling of wind just roll all in the car, like driving with the windows down and feeling that wind all around you. And then I was thinking of astronauts. Excuse me. Well, there's no wind out there. There's no wind. So there's no wind. Like, if you're going to go on Mars, if you're going to be the first pioneer to go on Mars and plan on never returning again, you're never going to feel wind. That's wild to think. Like, that is wild to think about. This simple thing of, everyone said there's all these songs about feeling the wind in your skin and in your hair and in your eyeballs. Maybe not in your eyeballs, but there's all these songs about it, or people talking to you, just feel the wind, and you're not going to feel that up in Mars. It's going to be a completely different life experience. It's going to be really wild. All right, I'm checking on my systems. I have to fix something, guys. We're only, let me see, 8 minutes in. 8.50 minutes in, and I gotta go do a technical thing, but that's okay. We'll keep trucking along. I'll be right back. Okay, we're back. I got my hairs cut. Finally got my hairs cut. Yep, but I gotta tell you, thank you to my friend C. Like, what an amazing friend to send you a tutorial about how to cut your hair, because it was getting so long that when I would pee, I would stand up, I pull all my hair to the front, and I stand up, I would tuck my hair into my pants. I'm like, I can't be having this. This cannot be happening. So I sent a text message to my friend, and I'm like, you cut your own hair, how you do that? And she sent me a whole tutorial about it, and it was amazing. And I went to do it, completely chickened out. But what a friend, what an awesome friend that is. And it's, at the end of it, she was like and subscribe. But I went to get my hairs cut, and my hair, the hair dude, I go to the hair professional. He is one of the most interesting, smartest human beings I know on this planet. He has an extremely successful hair business with very extremely high profile clients. I'm not talking about famous people. I'm talking about people, those CEOs of companies, or people who own companies, that's extremely lucrative companies. So, and he just has some of the best, his own life stories I've ever heard. And it's just a real treat whenever I go quarterly. I go quarterly to see him. And that's one of the things I did last week. I know, so excited. A lot of comedy prep, guys. I've been writing a lot more, and just really getting dialed in on my stand-up. And I write, here's the thing, my writing is good. Should be. Half of my life in college was a journalist major, and then I switched that beach on. But yes, I placed second for my article about the Bethlehem Steel. My grandfather, he used to work there, and I interviewed him, and then I wrote an article about it. And so anyway, it's fun, and I like writing. I'm not like the best at it, but that helped me. I didn't know I was going to be a comedian, but at the time I was going to college for that, but that helped me, those skills did help me with my comedy writing. And so I write good jokes, but here... it's my delivery. There's a few things that need to happen when you're on the stage, the universe has to come together where you are harmonizing with the audience. You have to be with the audience. It's not something you can just pop up on stage and start rehearsing the thing, that you wrote. You're just going to rehearse it like a parrot and then get off the stage. No, you have to. It's very. You know what it is. You know what it reminds me of. I told my husband this the other day, and this is with any kind of communication, sales. You notice, like when you're doing a job interview, when you're a salesperson, the software sales or any kind of sales. But in comedy, what I have experienced is, it's very sensitive. The energy to make comedy work is extremely sensitive, and it reminds me of quantum entanglement, entangled particles. You have to keep entangled particles at absolute zero, or you have to keep them like very tightly confined, like they can't, in straitjackets, basically. They can't move or they will become untangled. It's called decoherence. And they're very, very sensitive to vibrations, to noises, to any kind of temperature changes. I mean, anything in the environment, these things can make them decohere very easily. And that is the kind of fragile nature as a comedian, that you need to understand this fragile nature and how to navigate it. And you have to respect the fragility, and you focus and be there with the people. It's like Dana Carvey said, it's like making music together. Like, you're saying a joke and it's going to the audience, and then the audience is they're listening and taking it in, and then they laugh, and then it comes back to you, and it's a very that's the noise it would be, but no. So you guys understand what I'm saying. But basically, so I'm just getting more dialed in with that, and I know that something I've got to work on. I have to work on everything, okay? But my writing's good. It's my delivery. Good God. And y'all out there are shaking your head. But yeah, I mean, hey, Dip, I see what's up. I see what's up. I see what I need to work on, and I've been working on it. And it's gotten way better since I first started stand-up comedy. And I just continue to work on it. But I want to get to a point where I have so much confidence in comedy that, like, as much confidence as I have in sewing a quilt, I can sew a quality quilt, and I can bake a mean muffin. And I want to be that confident in my skills in comedy as I am sewing a quality quilt or baking a mean muffin. I can also in the gym. Like, I'm super comfortable in the gym. Well, okay, let me go back to that. The gym is uncomfortable, but I am confident in my skills to navigate the gym and know what to do to get the results I want, and I know how to do it. And so I'm not saying I want to get comfortable. I'm saying I want to get confident. That's what I'm saying. That and I will, and it will happen. And because we're just up here, we're retard maxing. That's what's going on. Sometimes you gotta just retard max in order to fail forward. And do that, you gotta put the time in. The universe is like, oh, you want to be good? Well, here's your time card. You gotta put this time in, girl. And then you can get to this level. So that's what we're doing over here. You know, I was having dinner with Ted Sarandos and Richard Kind the other night, and Ted just kept trying to pitch me ideas for a show. And I was like, Ted, I'm trying to eat over here. Wild, right? Wild. Yeah, Arsenio Hall is doing a book tour right now. So he's going on a bunch of podcasts. And I just learned that he is 70 years old. Holy smokes. Dude doesn't look 70, but it's wild to think of like these comedy giants. And I guess you just always think that they're young in your head, and he's amazing, but God, I didn't know he was 70 years old. Jeez Louise. So what else is going on, guys? I love being here with you guys. Thanks for being here with me today. We're kicking off a new week, and we're going into the weekend, and you know what? That's where we're going. We're living another day in the life. And I got some improv things coming up, and I'm looking forward to that. And, I think if a laryngologist was listening, all of my impressions are a laryngologist nightmare. I did that on purpose. Take a breath. It's breath support. Breath support. I had to go to a speech therapist to help me with breath support. Okay, sorry guys, that was like right in your ear. But yeah, with breath support and to help correct my stutter. Now it wasn't that bad, but sometimes you'll hear it come out, and I wasn't making my mouth enunciate words all the way very correctly because I had poor breath support. So that's what we worked on. And sometimes when I do my impressions, that all goes out the window. So let's get on into it. I wanted to show you here. I talk about bot farms. Especially, gosh, I haven't talked about this, but I've noticed on Twitter is where I try to just post in Ghost, but on my stand-up clips, oh, good Lord, they come out of the woodwork. I don't know why. They're just programmed to do this. The AI bots, the mini bots, I call them mini bots, and they're so mean, but they're not real. And I just post and Ghost. I don't even read comments on TikTok anymore. Yeah. Excuse me. Twitter is the place where I get the kindest comments. Instagram is just crickets, and YouTube is a mixture. But TikTok is just full of those bots, and I just wanted to remind everyone just to post and Ghost. If you're on the socials and you're posting, get the frick out of there. That's what I'm saying. And because here's a good example of these bot farms. Someone posted this on Twitter. God.
Where you from, Jack?
Moon chow. Ni hao. So that's literally what's happening. That is what is all of the that's all the rage bait. They're just over there rage baiting. They're rage bait maxing. That's what's going on over there. So just know that, okay? And just know if you answer any of that, that's what you're answering. And that's why they usually never answer back. And just get out of there. Get out of there. Get on down the road and go pick a project that you can retard max out on. Come on. Let's go. All right, so we have, holy smokes. This is wild. wild. This is absolutely mind blow out your daggone butt. Okay, now what happened was in there was an airman who went down with a plane, and this was recently in the news. Went down in the plane in Iran, and he was there, and then we had to go get him. America had to go get him. Okay, so how the heck do you find an airman that went down like that with just no tools? I mean, how do you do that? They found him pretty quickly, and I'm not going to comment on what's going on. Like I said, Trump's out there. He's drinking alien blood out there, twittering. He's doing the tweets. Wild stuff going on. That's what's going on. But what really caught my eye with this was the tool that they used to find the airmen, called a Ghost Murmur. And this thing just blew my freaking mind right out my peach. Holy freaking smokes. I mentioned quantum entanglement a few minutes ago, and this uses quantum entanglement. What? Quantum entanglement is when two particles are entangled, and that's, if you want to find any more about quantum entanglement, look up Einstein and spooky action at a distance. And that was him. He discovered quantum entanglement, and he called it spooky action at a distance. And honestly, I think he was just looking out a window, and he saw a woman who was PMSing and on her period, and I think he thought that was pretty spooky, and it was at a distance. But he said, no, I wasn't talking about the lady outside who was on her period, just scrounging around for snacks. I was talking about this entangled particle thing. So I know, y'all love my cheesy jokes. Don't worry, I don't say that one on the stage. Good God. I thought she said she was a good joke writer. Good God, guys. You think I go out on stage, I say something ridiculous like that? Come on. Let's get some more coffee. Ooh. Okay. I said ooh because I thought I found something floating in my coffee. I have been trying, went back to the Keurig. I know, so bad. Plastic particles and this mainstream coffee, which I'm sure has a whole bunch of mold in it, and cockroach juices, and it's disgusting. But guys, it's affordable, so what do you want us to do, Rhonda Patrick? What do you want us to do? God, we can't stand there and spend, 10 minutes making coffee in a machine that has no plastic parts. A machine that has no plastic parts is like $1,600, by the way. Holy smokes. I mean, gosh, it's just, so then we just drink the Keurig and we send some prayers up to the Lord and eat some broccoli, and hopefully that stuff come out your body. That's all I'm saying. Let's get more coffee. Getting the blood moving, circulating that caffeine. That's what I'm doing. I'm stacked this morning. Okay, so, and by the way, I want to mention, I've been getting some requests about, am I married? Yes, I'm married. I didn't realize I wasn't wearing my wedding band. I'm wearing my wedding band today, and I'll be doing that in the future. But yes, I'm married. Thank you. I'm flattered. I'm flattered for the questions. Thank you. And also, I would like to see at least, I'd like to see some comments about like what's your workout routine and what's your hair routine. I want to see like a couple of those comments down there. Okay. Here we go. So the Ghost Murmur, I got my Hans device on because this is going to, like, this technology, when you learn about this technology, it's going to snap your head right off your neck. Here we go. The Ghost Murmur, and I'm talking about, it's a the major news break from, that was last week, involving a secret CIA technology called the Ghost Murmur. And let me see if I could play this. I didn't listen to this clip. How long is it? It's 1:49. It's the CIA director talking about the Ghost Murmur.
As an agency, the CIA possesses unique capabilities that only the president can deploy. Some of these capabilities fall under covert action authorities.
This is John Ratcliffe.
Covert means exactly that. I'm not going to be able to tell you everything that you want to know.
All right.
At the president's direction, we deployed both human assets and exquisite technologies that no other intelligence service in the world possesses to a daunting challenge comparable to hunting for a single grain of sand in the middle of a desert.
Did someone just go, Yep, that's right. Someone in the back there, over there. What is this? What is this, church? So I'm just gonna pause it there because I'm gonna explain this a lot. I was say faster than he is. He's not going to explain the whole thing about how this works. I think he just mentions that they use this Ghost Murmur thing. But here, I want to explain how it works because this is what really held my attention. So the Ghost Murmur, it was, the system was developed by Lockheed Martin's Skunk Works division. That's the secretive advanced development group responsible for the U-2 and SR-71 Blackbird. Those are airplanes. Or jets, rather. The name Ghost refers to finding someone who is effectively vanished, and the murmur is a medical nod to the rhythmic sound or electrical signature of the heart. It detects a heartbeat. This was from 40 miles away. And how does that work? The system developed by Lockheed Martin's Skunk Works. So it's wild to think about. It's a system that detects a heartbeat. And in this case, it detected the airman's heartbeat from 40 miles away. It's wild to think about, but your heart is basically a low power radio station. Every time it beats, it sends out a tiny burst of electricity to make the muscles contract. That electricity creates a microscopic magnetic field that ripples out into the world. And guess what detects those bichons? Entangled particles. You want to tell me that the earth, that life isn't about signals and electricity and things feeling other things from 40 miles away? Particles being affected by a magnetic ripple, a super, super soft magnetic ripple from 40 miles away. Holy smokes! Whoa! God, that's incredible. So let me tell you what I'm talking about here. It's the heart's fingerprint. A heartbeat isn't just a random pulse. It's a very specific shape. You see it on an EKG monitor. That shape creates a unique electromagnetic signature, a distinct pattern of energy. Even at 40 miles away, that tiny signal is technically there, but is buried under a mountain of noise from the Earth's magnetic field, power lines, and radio waves. And this is how this device works. So you're imagining these, we're out there, we're looking for the airman who's down in Iran. And he's hiding. And we're like, oh my God, we need to find him. Okay, we gotta go find this guy. So now we're like in a plane. We're like, how we find this guy? And they're like, well, they gave us this Ghost Murmur thing. Let's use it. So this Ghost Murmur thing, what it is it's a synthetic diamond, one grown in a lab. These are better than natural diamonds because engineers can control exactly where the nitrogen vacancy centers go. So it's a synthetic diamond with nitrogen vacancy centers. And I think that's like little, let me see, bear with me. It's like little holes, the diamond, yeah. So, the electrons in the hole, the vacancy. So it's like quote unquote holes where the electrons are. So to the naked eye, it looks like a tiny clear sliver of glass. So it looks like a little sliver of glass, maybe the size of a grain of rice. It's mounted inside a 3D printed gasket. It's a protective holder to keep it perfectly still while the plane vibrates. So this Bichon is on a plane, all right? And the plane's going, and so you have to keep this thing protected. And so it's not moving all over the place. It needs to stay stable. That's why they got it in a protective holder. Now there's a green laser. This is the power source. The green laser is a small diode laser, similar to a very high-powered laser pointer. It is permanently aimed at the diamond sliver. So you have this sliver, and then you got this laser pointer thing, and it's permanently aimed at the sliver. And here's why. Because there's particles in that diamond that are entangled, and when that little green laser hits the particles, they do a thing, and then right before they become decohered, they become untangled, the laser hits them again, so they become entangled again. So those Bichons keep getting hit up. They're entangled, and then they get hit, and then they do a thing, and then they start falling out of entanglement, and then they get a nice little jab, a nice little a pulse. They call it a pulse. Bing! And then they're entangled again. Maybe they don't want to be entangled with the other particle because the other particle is very loquacious. It just keeps on talking about the weather, the other particle, but you're zapped and pulsed into being entangled with this other particle. That's how I imagine it. The green laser, in a plane or a drone, the laser is constantly pumping the diamond. This puts the trapped electrons into the high energy state. Because the laser is hitting the diamond is constantly glowing red inside its housing. And to be clear, there are electrons inside of that diamond that are entangled. So the Ghost Murmur is so complex because they have to keep retangling the particles so they can keep using this connection over and over again. So when they're plucking the particles with this green laser. So basically, before you look at, there's A and B particles. Before you look at A, both were spinning coins, both up and down at once. The moment you plucked A and saw up, the linked decohered snapped, and B was forced to land on down. And then they gotta zap it again to get them recohered, basically. Does that make sense, guys? So this device is amazing. The spectrometer, the eyes. Next to the diamond is a high-speed photodetector, a super sensitive light sensor. What it sees, it isn't looking at the airman. It's only it's looking only at the diamond. It measures the brightness of that red glow. So remember, I said if you were to look at this thing, you would see because the laser is hitting the diamond is constantly glowing red inside its housing. So if you were to look at this little setup, this gasket thing with the Ghost Murmur, with the diamond in it and the laser pointed at it, it would look like just a glowing red thing inside the box, like this glowing red thing inside a box. That's really cool. The system, let me make sure. Okay, so the green laser in the diamond, the electrons are like a choir that has stopped singing and started talking all at once. They decohere. When the green laser hits them, it provides a massive burst of energy that shocks all the electrons back into a specific starting state. It's like a conductor tapping their baton on the podium. Everyone stops talking and looks up at the same time. This is called initialization. So that green laser keeps hitting those bichons to initialize them, get them back in order. Because the nitron, remember it's a nitron vacancy, they call it, in this synthetic diamond. Because the nitron and the electrons are trapped in the diamond lattice, which is the 3D grid of atoms, they are physically forced to stay close to each other. Since they are so close together, it is much easier for them to feel each other and relink their quantum states. I call it a straitjacket. It's kind of like a straitjacket. They put them, they pack them in there like those train cars you see over in China where everyone packs into those trains. It's kind of like that. That's what I think. It'd be easy to communicate on that because everyone's so close together. The system doesn't just entangle them once and hope for the best. It works in a lightning fast cycle. The entanglement, the green laser initializes the electrons. The system waits for a few microseconds to see if a heartbeat magnetic ripple nudges the electrons. And I'm talking about the heartbeat of the airman. The photodetector measures the red light to see if they were nudged. That's called the Zeeman effect. The green laser fires again to retangle them for the next measurement. This happens thousands of times every second. Even though the entanglement breaks every time they take a measurement, they retangle so fast that to the operator it looks like a continuous live heartbeat from 40 miles away. So that, oh my gosh, let me tell you about the Zeeman effect. If a magnetic field like the one from a pilot's heart passes through the diamond, it splits the energy levels of the electrons. The split changes how much red light the diamond gives off. The diamond actually flickers or dims in perfect sync with the heartbeat 40 miles away. The electrons are so sensitive that they feel the magnetic ripple and report it instantly by changing their light output. And then they have something to detect that whole process, because you can't, like I said, you can't see that pulsing. It is pulsing with the heartbeat, like that light pulses with the heartbeat. The diamond actually flickers or dims in perfect sync with the heartbeat 40 miles away. The electrons are so sensitive that they feel the magnetic ripple and report it instantly by changing their light output. We can't see that. Our eye can't see, our eyeballs can't see that. We just see a glowing red diamond thingy. So that's why you need AI to read that. And entanglement, there's something called, they keep them entangled, and there's something called the squeezing the noise. Entanglement allows the system to reach a squeezed state, a quantum trick to push all the static into a different measurement so the magnetic field reading becomes crystal clear. Are you guys understanding this? This is wild. I mean, it just blows my dang mind. You thought quantum was dead? You hear about quantum and you're like, we're never gonna use that. Well, it is very much alive. This is not the only quantum device I'm going to talk about today. We're going to move on to a quantum cybersecurity method that they are using in the Artemis spacecraft right now with entangled particles. But back to the Ghost Murmur. The system relies on quantum entanglement, like I said, a phenomenon where particles become linked so that the state of one instantly influences the others, regardless of distance. To pick a heartbeat from 40 miles away, you have to overcome quantum noise, that's random atomic interference. So, by the way, they're not using single electrons because, why don't they just use single electrons? This whole quantum thing seems a little too complicated. A single electron is very jumpy. They react to everything. They react to heat. They react to noises. They just go like an ionized molecule zipping around. Those electrons, they react to everything, like your Aunt Rita over there in the Bronx. Aunt Rita, she reacts to everything. Or my mother-in-law. Love you, mother-in-law, but you are very reactive, like an electron. So when electrons are entangled, they act like a single giant choir singing the same note. And then they keep hitting those bichons with that green laser to keep re-entangling them and getting them all back together in that choir. So because they are linked, because entangled particles are linked, the random jumpiness of individual electrons cancel out, leaving only clean signals of the thing you are trying to look for, aka a heartbeat. That's called quantum gain. Really? That's called quantum gain? Wow, I've never heard of that. No, I think MIT talks about that. Oh, Georgia Tech over there, they talk about that too, but I don't hear it out here in the wild. That's amazing. It is amazing. Without entanglement, the signal would just be static if you were just using those very jumpy, very reactive electrons. Those like Aunt Rita. So by entangling the electrons within the diamond sensors, they act as a single coordinated unit. This allows the sensor to reach a level of sensitivity called a squeezed state, and I just talked about that. And it allows it to hear a single heartbeat in 1,000 square miles of desert. Holy freaking smokes! So in order for the particles to stay entangled, typically you would need, most systems need to be near absolute zero. You've heard of the quantum computer, where they have all that copper and all the things to keep the particles all entangled, and then they got to put it like 500 feet under the earth or something like that. But yeah, and they have to keep them all entangled so that they don't decohere. If a single warm air molecule touches them, the quantum state collapses, decoherence. They're like delicate snowflakes. But the loophole that this Ghost Murmur got by, it's by using that nitrogen vacancy centers in diamonds. The diamond's rigid crystal lattice acts like a suit of armor. It holds the electrons so tightly in place that they are shielded from the heat vibrations of the outside world. This allows them to stay entangled at room temperature for a relatively long time. So basically, it's a straight jacket. And these entangled particles, well, now I think they're just kind of becoming indentured servants. That's what's happening. But, a thought just occurred to me right now. How do these, the Ghost Murmur, like the people using it, the people in the airplane who are using it, and I don't know if they use it in an airplane, but I'm going to assume that they use this device in an airplane because on the ground there's just too much, it's too risky, and there's just a lot going on the ground. But up in the air is like a little less things going on, a little less vibrations, I would think, and maybe I don't know what I'm saying, but anyway, up in the air it seems a little safer. That's all I'm saying. So since the people who are using this Ghost Murmur, how is it not detecting all of the heartbeats of the airmen in the airplane? Okay, we're back. I asked Gemini how the Ghost Murmur was only able to detect the airman on the ground, the guy that they were looking for, and not get all of the other people's heartbeats who were using the device to find the dude, not get all their heartbeats all convoluted and mixed up with the dude on the ground's heartbeat. You know, how did that happen? And so this is what Gemini said. Every human heart has a slightly unique electromagnetic signature. And I did mention that in the beginning, talking about the Ghost Murmur. So basically, all these different waves, the P wave, QRS complex, and T wave on a EKG, the CIA reportedly had the airman's pre-recorded heart signature. The AI was programmed to look only for that specific pattern, effectively hitting mute on everyone else's in the plane. So they had to have everyone's heartbeat recorded and then feed that into the AI and said, all right, or maybe they didn't. No, I'm thinking about that too much. I'm not retard maxing. They fed the airmen on the ground. They're like, this is the one we're looking for, and don't pay attention to anyone else's. That's what they did, because doing it the other way is just ridiculous. So, wow, that is amazing. And what's amazing, I don't know why I did that. Amazing. That's amazing. Isn't that right? That's okay. That's wild. You said quantum entanglement. What to find the dude on the ground? What? You said that really worked? Oh my God! And that's the first time they used that, huh? I think that's the first time they used that. Wow. Whoa. Holy smokes! That's really cool. Okay, moving on. Moving on to more quantum talk. So fun. We're going to talk about Artemis. The Artemis flight. Remember that spacecraft that went and it launched up to the moon? And that was NASA over there who launched that spacecraft. And they're up in the moon. They're not in the moon. They're seeing the moon. And okay, let me see here. I have a post. NASA's Artemis II will test laser-based communication from the moon, streaming data by light across from space. Now, what does that mean? The shift to communication by light is one of the most significant upgrades in space history. While we have used radio waves since the 1960s, yes, the 60s were a great time, kind of. They had some interesting things. You know what they had in the 60s? They had this concept of a sitting lawnmower with this bubble, and then it was air conditioned inside, and they have the guy in there doing the lawn, and then like the family, the mom, like the lady, his wife, and the kids are like in the yard waving to him in the heat. The lady and the kids, the wife and the kids are in the yard in the glaring heat, and they're waving to their dad and their husband like, "Hey, you in that air conditioning, in that bubble thing?" And that's what was going on in the 60s. That's what they were conceptualizing. That's what was going on. So while we have used radio waves since the 60s, Artemis II is the first crewed mission to use a high-powered optical communication system known as O2O. O2O reporting. O2O reporting for duty. Here, so let's see. The breakdown is RF versus laser. Okay, that's RF is radio frequency. And ladies, you've heard of radio frequency. You put that on your face to make it look pretty. That's what you do. And sometimes it give you a headache. And that's probably not great. It's probably rewiring things in your brain. And you might want to just get off that radio frequency. But, what do I know? Traditional radio frequency signals are like a flashlight. They spread out a wide swath. That's what I say. It's a wide swath. And that's a cone. So the radio frequency signals, they like you're up there in the spacecraft and we're trying to communicate with Earth and we're sending these radio frequency signals down, but it's spreading a wide cone, and that's a cybersecurity. I mean, where's the cybersecurity in there? There is none. It's mute. You think there's any cybersecurity in a radio frequency cone communication signal? Nope. Not in the 60s. So it's a problem. By the time a signal from the moon reaches Earth, it covers an area hundreds of miles wide. It makes for leakage, easy for an adversary to detect and intercept the data. Optical communications laser. Now, this is what they're using on Artemis II. They're testing this out. It's like a sniper rifle. It uses a collimated beam, a light beam where the rays are perfectly parallel and do not spread out. So it's very focused. It's it's like you're getting focused on something, you are dialing in. You are getting optical communications lasered in. That's what I say. That's just out there, and people look at me and they're like, I don't know what you mean, but that's what you're doing. You're focusing the light beam. It's just like a light beam. And everyone knows what a light beam is. So cybersecurity benefit: to hack or see the signal, you would have to physically place a satellite directly in the narrow path of the laser beam, which is essentially a needle in a haystack in deep space. So back in the 60s, and also, guys, we've been using this since the 60s, by the way. So since the 60s, since we've been using this, everyone be knowing all of our biznack. That's what was going on. So it's low probability detection, this optical communications laser. So it's a military grade security standard because the laser beam is so narrow and uses infrared light just outside the range of what human eyes can see. That's what human beings give off. We give off that infrared light. A third party wouldn't even know a conversation was happening unless they were looking for that exact tiny point in the sky. Let's see. Resistance to jamming and spoofing. Jamming, which is flooding a frequency with noise to drown out a signal, is very effective against radio. However, it is nearly impossible against laser. Because the receiver is looking at a specific photon-based encoding, information hidden in individual particles of light. What? What did I just say? Okay, I'm talking about the optical communications laser that the Artemis II is testing out to communicate back to Earth. And there's something called, it's resistant to jamming. And it's because the receiver is looking at a specific photon-based encoding. Information hidden in individual particles of light. There's information in individual particles of light. Holy smokes, there's information all around me. That's for sure, because I got a lot of lights up in this piece on. There's information all around you too out there. You got sunlight, there's info in those particles. Holy smokes, that is wild. That's freaking wild. An attacker would need a massive, perfectly aimed laser of their own to interfere with the signal. All right, all you attackers out there, try to crack that code. God, those particles, those particles... You're not going to make small talk with a particle. You see these particles walking down the street, and they have information hidden in themselves, in particles of light. These light particles are walking down the street. You ain't going to go talk to those particles about the weather. That's all I'm saying. Wow. Whoa. That is wild. Okay, so it uses quantum. We're talking quantum entangled part of it. It's called quantum key distribution. So here is another technology that uses entangled particles. Thank you, Einstein. I just thought I had to get that in there. This is the holy grail, the quantum key distribution, the holy grail of cybersecurity. It uses entangled particles that are linked so they share the same state regardless of distance. I can't explain that. I tried to wrap my head around that. I can't explain it. So go ask Grok, and maybe you can do a better job of trying to conceptualize entanglement. Why is this unbreakable? Why is the quantum key distribution unbreakable? If someone tries to intercept an entangled particle in a laser beam, the particle's state changes instantly. They decohere. We just talked about that. You know what that is now. The astronauts would see this glitch and know the line was compromised before any secret data was actually sent. So let's see. Let's recap. If someone tries to intercept an entangled photon in a laser beam, we're talking about that quantum key distribution, which uses entangled particles. Okay. If someone tries to intercept this in a laser beam, the particle's state changes and they instantly, I'll say disconnect, they decohere. They're not together anymore. They broke up. Johnny and Jessica over there, they broke up. Because someone trying to get all up in their business, they got angry, they got irked at each other. That's it. So when that happens, the astronauts see a glitch and know the line was compromised before any secret data was actually sent. Holy all right, I am convinced. I'm convinced that these entangled particles that are used in the optical communications laser on Artemis II with the quantum key distribution, okay, entangled particles are used there. And also entangled particles are used in the Ghost Murmur, the little diamond thing, nitrogen diamond thing that was used to find the airmen on the ground in Iran. That uses entangled particles. I'm convinced that entangled particles have now become indentured servants. And we're putting them like in straitjackets. We're making them be in very, 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 very confined spaces. Like those trains in China, they all pack in there like sardines. We put those particles in there like this, and then we make them be entangled with each other so that they're all together. And they're like a choir, and they're all together. And then when they become decohered, we just zap them with a laser to become entangled again. So not only are they indentured servants, but they keep getting zapped back together. God, I think we need to start a movement with rights for particles. And these particles should be required to be put in movies. It should be required to have a character part in every single movie, even if it doesn't make sense. And also, they should have their own cooking show on the Cooking Network, even if it sucks. And we should be getting those rights for these bichons. So I'm gonna go get my Kevlar jacket, and I'll be right back. And we back. All right, I've talked about this before, and called the Great Filter. Well, probably not in a while, actually. The Great Filter, I am very much into this. I mentioned it last week in my podcast, but I got the theory wrong. I thought it was the Fermi paradox, but what I was talking about was the Great Filter. And what I was saying was we only have, to me, this is what I believe, we only have a certain amount of time to get off this planet to become a multiplanetary species. And it's very important to me that we do that because Earth isn't going to last forever. And I think the free world is very fragile. And we got to go and get another one for everybody. And it needs to be like redone without all of the previous issues. We just need to start a whole new world for people to live in. And we can do that with Mars. And that makes me excited. And but we only have a certain amount of time to do it. And who's doing it? Elon Musk is doing it. He envisions the von Neumann probe where It's the self-replicating robots. That's his vision of the von Neumann probe. And you have robots that go up there and then they replicate themselves and they build infrastructure for the first human settlers to go up there. And also, I talked about Jason Ballard of Icon. He also envisions his 3D printers to go on up there in space. He is contracted with NASA to get on up on the moon and print some infrastructure so human beings can go up there and do things. So we're making it happen, Captain. But those two guys, there's not a lot of people doing it. That's kind of it. So I'm sure there's other companies out there that I haven't come across or researched yet, but I know those are the two biggest ones that I have been following for a few years now. And we only have a certain window it's called the Great Filter. It suggests there is some developmental steps so difficult to overcome that it prevents almost all civilization from reaching the stage of interstellar travel. If the filter is behind us, we are incredibly lucky and might be the first to make it out this far. For example, the jump from single-celled to multi-celled life was the filter. We passed the filter. The filter was behind us. If the filter is ahead of us, we are in trouble. This means most civilizations reach our level of tech, but then hit a wall and go extinct. That's not great. So the specific it's like a short window I mentioned. It refers to the idea that a planet only provides a brief period of geological and biological stability combined with accessible resources. If a civilization doesn't use its easy energy like fossil fuels, the sun, we're not using the sun. Fusion, we're over here, people are over here trying to make fusion on Earth, like little mini suns and boxes. There's one up there. What are you doing? Holy smoke, we got to get Dyson spheres up there. Come on, and I'm not talking about the vacuum guy, Dyson vacuum guy. Those are the worst. Do not put those up there. They'll break in 6 months, and they're so expensive. But no, what I'm talking about is a Dyson sphere, and it uses the sun, it rotates, gives energy. We need to start doing that. Yeah, that's the Kardashev scale. Type 2 civilization, let's go, that uses the sun for its energy. And if a civilization doesn't use its easy energy to launch into space and find new resources, it may exhaust those resources or destabilize its environment, like nuclear war or resource depletion before it has the tech to leave. Once those starter fuels are gone, the window shuts because there isn't enough energy left to try again. And that's happening. So we have a window open right now. It is slowly closing. I mentioned the Fermi paradox last week. The Fermi paradox is the name for the contradiction itself. There are billions of stars like the sun in the galaxy. Many of these stars have Earth-like planets. Therefore, we should see evidence of alien life, but we see nothing. Why? I feel like we're alone. I know there's Bob Lazar, and he sounds super interesting, but he himself seems very skeptical about aliens, but he talks about the spacecraft that he saw. But it's I don't know, man. I feel like we're alone in the universe, and that's not great. Does that mean that we never made it off this planet? Human beings started over and started over and started over. Gone extinct, started over, gone extinct, started over, and we just never got off this planet. Oh my God. So the brief window of habitability, some scientists argue that Earth-like conditions are temporary on a cosmic scale. Eventually, the sun will expand and boil the oceans, meaning we have a finite evacuation deadline. The sustainability bottleneck. This suggests that civilizations naturally collapse under the weight of their own complexity or environmental impact before they can become type 2 civilizations capable of harnessing the energy of their entire star. That's the Kardashev scale that I mentioned. So I want to talk about that because I think about these two things, the Great Filter and the Fermi paradox, probably every day. Maybe if not every day, multiple times a week. It's just something to think about. Let's give it something to talk about. Oh, gosh, I hope I don't get nixed for that, for singing. You know what? YouTube cannot detect my tune. I can't hold a tune to save my life, so I think we're good. All right, the last thing we're going to talk about is Phantom by Foundation. This is another military-grade equipment, and I know I'm talking about a lot of military-grade equipments, but like they seem to have all the money and resources to be building this really cool tech, and they have reasons to build it. So what's happening? So we're talking about Foundation, and that is a American company. Foundation was founded in 2023 in San Francisco. It is strictly an American company. Total raised over there, 21 to 24 mil. And that's CEO, that's Sankate. Oh boy, Sankaet Pathak. I hope I said that right. Sankate Pathak. Let me see. What would my speech therapist say? Take a breath. Sankate Pathak. And then you got your breath support. So Sankate Pathak. I'm going to say Pathak. Pathak is sitting on a whole pile of cheese over there at Foundation. And that's wild. Now, when I tell you about this robot, Foundation's flagship robot is Phantom. Phantom is contracted with the military. I talked about them back on my Milkmaids of Mars episode, and I talked about them, I think, in depth, and we're going to talk about them again because they just got contracted with the military. And so here we go. Don't swallow your kazoos, folks. Don't swallow those kazoos, everybody. Here we go. Okay. Phantom MK1 aligns with the combat-ready humanoid movement that has been gaining traction in early 2026. This is the news section. Yes, this is a update on the news. That sounded very newsy, didn't it? Okay, here we go. Combat-specific design. So this robot. Let me make sure I have idea of you, image of this for you. Oh, is this AI? No, it's not. All right, so, okay, maybe that first one is the robot running with the dudes, but I think he can do that. So the Phantom MK1 is the first U.S. humanoid robot built explicitly for combat. $150,000 a unit ballistic armor. Stealth coating that hides it from thermal sensors. We'll get into that because that's interesting. It can carry, we're going to go imperial here. Okay, guys, 44 pounds. All right, I'll go to metric for you then. That's 20 kilograms of weapons or equipment. Reports claim 2 units are already being tested on the front lines in Ukraine. Here we go. And this is, like I said, I talked about this in the Milkmaids of Mars episode months ago. And I know that Pathak was talking about how he wanted his robot to be extremely sturdy and military grade. And he was very adamant on using cycloidal gearboxes, and specifically cycloidal quasi-direct drives, instead of those harmonic reducers, and actuators in the joints. So what I'm saying is, in a robot, and also what makes them expensive is these joints. That's not the only thing, but they are expensive. So for every single joint in a humanoid robot that looks like us, they got feet, they are bipedals, they stand on their 2 feet, and they got arms and a neck. They got that C6 C7, and all the L's up their spine. No, but they stand upright like us, and they're built to look like us. So they got knees, and they don't really got the toes yet, but they got the fingers, they got the hands, and the elbows, and the shoulders, and the hips, and all of those joints. They need an actuator or a harmonic drive in order to do anything, in order to bend. And a hip harmonic drive or actuator could be like $1,200 just for one. Probably more if you want like a really good one. And so the little ones in the fingers, those could be like $200 a piece. So that's what makes them expensive. And if you have a domestic robot like Figure, we've talked about, your Optimus robot. There's a robot named Neo, and that's Norwegian, I do believe. They are all use these harmonic drives, harmonic reducers, actuators, and it makes them more slim looking. They can get around a house. They're not like big and clunky. But what I'm saying is Pathak is very vocal on how he is not using any of that. He wants his robot to be strong and sturdy and beefy. These robots be beefy. You see this robot and you're like, that thing can pick up a 40-pound kettlebell. Now then you look over at Figure and you're like, I think it can. But that dude's skinny. So but that's what I'm saying. You get it. You get what I'm saying without actually saying it. Good God. Let's get more coffee. Mm-hmm. Okay, so the cycloidal gearboxes, I'm going to put this into, I don't know why I'm having such a hard time trying to pronounce that. Let me get Gemini. Okay, so I'm back. I'm back with the right pronunciation, I do believe, of this cycloidal. A cycloidal gearbox. Now, Pathak, Sankiat Pathak is using cycloidal gearboxes, specifically cycloidal quasi-direct drives. These gearboxes are incredibly robust because they share the load across multiple gear teeth simultaneously. Unlike standard planetary gears, they are nearly impossible to strip during high-impact events, like a robot falling over on concrete or absorbing the recoil of a weapon. While they are slightly heavier than the sleek integrated actuators you see in party robots or stealthy looking robots like Figure or Optimus, they provide the torque density and shock resistance necessary for a machine designed for war zones and disaster relief. Unlike Figure or Optimus, which are designed for logistics and manufacturing, the Phantom MK1 is built for durability and stealth. The thermal coating is a particularly high-tech addition as it aims to solve the biggest weakness of high-performance robots: heat signatures from the massive compute power and battery discharge required to move. Wow. Now, the mention of them being explicitly built for combat is kind of, people might be a little shocked. They might be holding on to their chests, or they're holding on to their babushkas on their head, or maybe they're clutching their purses because they just cannot believe that you would have a robot built for the military. That should be outlawed. Well, let me tell you something. If you got China building them and then we're not building them, really? What do you think is gonna happen? Who's gonna be the one that might be looked at as the weaker one? Huh? Really? Do you like protection? You like to be protected? Then stop with all your stop being so didactic, which I'm doing right now. Okay, let me get this back onto the rails. So what I'm saying is it's built explicitly for combat. Do I like that? No. I don't like any of it. I don't like that we have these autonomous drones, and I don't like any of it. But it's weird. I heard someone, this is a while ago, on a podcast talking about nuclear weapons, and I think there's 9 countries that have nuclear weapons, but it is just crazy that it's like you have a country, it's probably China, they have, say, 3,000 nuclear weapons. I don't know the specifics, man, but basically 1,000 or like one of those is enough to just ruin all of humanity. But then, maybe they heard that the U.S. had, they start out with 1, and then the U.S. is like, we got 2, and then they're like, we gonna make 3, and then we're like, we gonna make 4, and then they're like, we gonna make 3,000, and we're like, we gonna make 3,000 too. It's like there's no reason for it. There's no reason to go that high, but that's just. Okay, going back to the great filter, we have a window that is closing. We got to get out of here. We got to get up in space. We got to get off this planet because things are getting crazy. But I mean, yeah. So, do I like it? I don't really like it. Do we have to do it? It seems like we have to do it. We have to have these things. We have to have a robot that is capable for combat because that's what everyone else is doing. We can't be the only people not doing it. So that's my stance. And, what the heck do I know, guys? I don't even get paid to do this. So, but that's the best. That's all. That might also be cool because I can just say whatever I want, really. But I'm trying to I'm trying to just kind of make sense of it all. It's all very interesting. Don't think too hard about it. You can't think too hard about things that aren't affecting your life directly. Let's just focus on picking a project that is going to add value to our life and go ahead and retard max on that, Big Sean, and get better at your craft. And so anyway, now I'm really like being didactic. Okay, let's get back on the rails. I brought us back on the rails, and then we went down a mountain. And we rolled a few times, went down a mountain. I think the roof came off. So let's get this Bichon back on the rails without the roof. That's okay. We're feeling the wind on our skin. So this Phantom MK1 is built explicitly for combat. So it's sending shockwaves through the industry, as many other manufacturers have no weaponized clauses in their terms of service. I know Boston Dynamics is very vocal about how they wouldn't weaponize their robo-dogs. And then I think the military contracted with a company called Ghost Robotics. I think they're out of South Korea, but they allow weaponization of their dogs. So things like that are happening. So this company here, it's an American company. They're go ahead and they're like, you can go ahead and give this robot. You can go ahead and put some things on it to make it military ready. And this robot does, I'm talking about like Figure and Optimus. They aren't weaker for not having cycloidal. I might need to play that again. Cycloidal gearboxes. Cycloidal gearboxes. So I'm not saying Figure and Optimus are weak for not having cycloidal gearboxes, but I'm not saying that at all. You don't, because here's the thing. You see this Phantom robot, Figure and Optimus, they have those like harmonic drives or like actuators, I think harmonic reducers in their joints, and they look stealthy and purdy and they can slim, and this robot looks like a military robot. I wouldn't want this in my house. I actually don't want this thing around me. Okay, that's it looks a little daunting. It does look beefy and it looks like it's capable. And it is. It sure is. It sure is capable. Okay, I got to... All right, guys, I have to fix something, and I'm laughing because that's the second time that's going on, so I'll be right back. Okay, we're back. We're back, Jack, and I'm stacked. Speaking of which, guys, I have some stand-up comedy opportunities in the future in the works, and so I'll keep you posted on that. But I really hope some more come my way, and I'm really hoping to get on Kill Tony. Now, I'm like, hoping is not a strategy, right, guys? Here, I have a snafu of flying out to Austin and then walking around 6th Street doing the mics. Grok told me not to do that. So it's like, bring a friend. I'm like, all my friends have kids, man. They go to bed at 7 o'clock. What you talking about? So it's being a female comedian, you got to just like creatively, work through that. If I could have a fleet of phantoms, hey, Sankiat Pathak. If I know your robots are expensive, $150,000 a pop, but if you could provide a fleet of them to me so I could walk around 6th Street in Austin and try to get on Kill Tony and try to get into the Comedy Mothership open mic and then walk around and do some open mics all in the vampire hours of the night when it's not safe for the ladies. If you could just let me borrow a fleet of your Phantom MK1s, oh my God. I would be, oh my God. My mind would blow out my freaking peach, man. If you did that for me, then I could go and I could try to get on those mics out there, because that's where it's at. Good God. Hope is not a strategy, folks. It's not a strategy, folks. Let's move on. So the brain of Phantom MK1, they have a proprietary system called the Foundational World Graph, and this is a proprietary neural net. It's much like Figure's vision language model, vision language action models. Foundation's AI is designed for end-to-end physical autonomy. It doesn't just recognize a door, it understands the physics of the door's weight and the friction of the hinges in real time. And I'll just go over end-to-end real quick. I talked about this last podcast, but end-to-end AI brain for a robot means in traditional robotics, the brain is usually built like an assembly line with several different teams that don't always talk to each other. That's like historic. If you're building modern robotics, it has to be end to end. So it has to be it collapses, an end-to-end system collapses all these separate boxes. So traditionally it was the perception box. The module takes in camera data and identifies objects. The mapping box. The module takes those objects and places them on a 3D map. The planning box. The module looks at the map and decides the best path to take. The control box. This module finally tells the wheels or motors how much to turn. So that's like traditionally, that is not an end-to-end model. So, and it was a problem because if the perception box misidentifies a bush as a rock, the planning box makes a massive unnecessary detour because it didn't have the raw context of what the camera actually saw. Bad information just going down the line, making all kinds of bad choices. Don't be that robot. Don't be an old robot. Okay, you want to be an end-to-end robot, and you want your system to be high-lev. Okay, you want to collapse all those boxes, those separate boxes, into a single massive neural net. That raw sensor data, the video feed from the camera, the output is the direct control commands, steering, braking, and acceleration. And instead of translating the world into a map first, the AI reasons through the visual data directly. It's much more like how a human drives. It's like a human being. Okay, Phantom MK's proprietary neural net brain, called the Foundation World Graph, is an end-to-end model that thinks like a human being. It thinks through problems and things like that, and it reasons through the visual data, and it all thinks like us. So when you see a ball roll into a street, you don't consciously label the object, calculate the trajectory on a 3D grid, and then send a signal to your foot. You just see the intent of the situation and react instantly, and that is how a modern robot is being built. So that's pretty wild. Their proprietary neural net, the foundational world graph model, is an end-to-end physical autonomy. And yes, they are a partner with NVIDIA. You can't do it without NVIDIA. They train their robot in the Isaac GR00T. This is from Gemini, so I'd like to talk to these people directly, like Brett Adcock. I'd like to ask some questions, but the only access of information I have is all of these large language models and books and articles and things like that. So this is where we are. So from what I've gleaned, we got Phantom was trained in Isaac GR00T framework to train their models in simulation before deploying them. We all know that, right? We know that at this point. It uses the Jetson Thor. In a combat or black ops robot, the Jetson Thor is the only thing that makes the thermal stealth coding viable. Compute efficiency. Thor is designed specifically for physical AI. It handles the massive multi-sensor fusion with much lower power draw than a traditional GPU cluster. Heat management. Less power draw means less heat. This allows Phantom to stay cold and hidden from thermal sensors while still processing complex tactical maneuvers. And there's something called... let me see if I can find it. A multi-instance GPU, MIG. And that's what that Thor is. So, because I was thinking maybe it has a dual Thor setup. But the Jetson Thor, there's a specific model of the Jetson Thor T5000 maybe. Don't quote me on that. But it's designed with something called a multi-instance GPU. And... technology. It can effectively act like multiple GPUs, partitioning one part for vision and another for motion transformer models. And basically, it can take the Blackwell, the NVIDIA Blackwell, and it can chunk it up. Like a robot can do real-time motor control and balance while doing obstacle avoidance, while understanding your voice commands all at once. One doesn't lag because of another's latency issues. And so it can take that Jetson Thor over there, and it can go ahead and divide that up into little sections. I believe that's called quantization, where you're taking a big, huge model and you're shrinking it down. You're not changing the architecture or anything. You're just shrinking it down to work for the physical AI that you are putting it in. Now, let's move on to something that I'm very curious about. So, in order to move on to this, we have to know how heavy Phantom is. Now, Phantom is about 176 pounds, 80 kilograms for you metric people, and it can hold a payload of 44 pounds. Now, it does have some massive battery. It has a lithium ion battery pack, and lithium is the fuel inside the battery. Okay, guys. So normally a battery is like nickel, which is heavy, or lead acid, which is super heavy. And a battery, like a regular battery cell, a dry cell battery with this nickel lead, it's 1.5 volts per cell. A lithium ion pack is 3.6 volts per lithium cell, and it's a 4-hour runtime. If you had to do and it's about 44 pounds, this pack. So if you had to do a 4-hour runtime with a standard dry cell battery, it'd be like 500 pounds, and that's not gonna work. So the lithium is the fuel inside the battery instead of that lead acid and nickel. It's the lightest metal in the universe. The atoms are so small and light, you can pack billions of them into a tiny space. And that is wild to me, the backpack. Of course, like, I went down a whole rabbit hole with this backpack. So the way a backpack, the liquid ion pack works is the ions means it's charged. I'm like, ion, oh, it's like ion, it's ionized, it's like radiation. No. Ion just means it's charged. It has gained or lost an electron. In this case, Phantom's battery lithium atoms, they lose an electron to become lithium ions. So the ions physically swim through a liquid called their electrolytes, and they go from one side of the pack to the other side of the pack. And the swimming is what creates the flow of electricity that powers the Jetson Thor, which is the GPU. It has that neural net on it for Phantom to think. It has their proprietary neural net, the foundational world graph on there. And let's see. I was like, why does lithium ion expire? It seems like it could just go forever. And it's a result of a chemical that happens inside a lithium ion pack. The very first time you charge a lithium ion battery, the liquid electrolyte reacts with the lithium to form a thin protective skin on the anode called the solid electrolyte interface. So there's this anode, and I imagine an anode like a probe. It's like an antenna or a probe, and I know that's not right, but it's like, so it creates this, the first time you charge this lithium ion battery up, creates a SEI, solid electrolyte interface, is like the skin that goes on it. I think of it like a snake skin. The skin is good at first. It protects the battery from further corrosion, but every time you charge and discharge, the skin gets slightly thicker. It steals the lithium ions to grow. What? It steals. Okay. And so, well, hang on. Forget that. That makes no sense. It gets thicker. It makes it harder for the remaining ions to pass through, basically. That's what I'm saying. So as the skin gets thicker, the ions can't get through anymore. So it's not that you have a lack of ions, it is that this skin gets thick and doesn't allow the ions to get through. So it can no longer deliver enough current to move, say, the robot's legs. Lithium plating. When Phantom is working hard or charging fast, the ions are rushing towards the anode like a crowd trying to get through a stadium gate. If they move too fast or the environment is too cold, some ions don't make it into the gate. Instead, they get stuck on the outside and turn back into solid lithium metal. It's called plating. Once lithium becomes a solid metal on the surface, it's dead energy. It can never go back to being a useful ion again. Over years, you lose enough liquid ions to this solid plating that the battery's capacity drops from 4 hours to 2 hours, and so on. Micro cracking, mechanical stress. Imagine the battery as a sponge. When you charge it, the ions soak into electrodes, causing them to physically swell. When you use the robot, the ions leave and electrodes shrink. Doing this thousands of times causes microfractures in the material. Eventually, pieces of the electrode break off and those electrical contact. It's like a bridge collapsing. The ions are still there, but they have no road left to travel on. So, even if you never used the robot and just left it on the shelf, there's something called calendar aging, and it kills it. So Phantom probably uses this lithium ion battery, but the certain flavor of it is probably nickel, manganese, and cobalt, and it's a version of the lithium because it's light and powerful. Nickel and cobalt make the battery super expensive and ethically complicated. Let's just say that. Y'all heard of those ladies out there in those cobalt mines, man? They're with their babies on their back and they're like breathing. Oh, geez, criminal. We got to figure out another way. And there's also a weather problem. So this makes me curious, and I asked Gemini twice to check its information to make sure it was telling me the right thing. because it wants to please you all the time. So you have to push back on it. And it said it was, but here's what it makes me think about this. If you have cold weather, which Ukraine is cold, okay? So Phantom is in Ukraine right now. That's what this post is saying. Let me get back to that post, by the way. Okay, so reports claim 2 units are already being tested on the front lines in Ukraine. All right, it's cold there, right? Here's the problem. If it's cold, freezing. It's freezing, okay? A 4-hour runtime drops to 2 hours because the ions move through the liquid like molasses when they are cold. So when those ions are cold as balls, they're freezing their tatas. Or as Clark would say from Christmas Vacation, it's a bit nipply out there. You know, these ions, they feel that, and they're going really slow. They're moving super slow. I think that's what we do, too. We move super slow when we're cold. So that's what they do, and that doesn't really make sense. I don't know. So I wonder if they're have some other way of combating that, but this lithium, that's the problem with that lithium ion battery. And there is a new, this is cool. There is a new tech on the horizon, and it's just kind of like the itty bitty, it's a thought. It's a little seedling at this point. The future of batteries, structural batteries, where they bake lithium into carbon fiber sheets. So the robot's body is the battery. And that's a wild thing to think about. I challenged Gemini. I said, what about carbon fiber? And that's what it said. So that's what's going on in the world out there. That's everything going on these days. And that's all we got today, guys. I hope you enjoyed this episode. I love being here with you guys. I look forward to it every single week. And I will see you next week. Signing off. Bye.